Hi, this is Ms. Palligren, and today we're going to be looking at Module 4, Lesson 4, Percent Increase and Decrease. Students solve percent problems when one quantity is a certain percent more or less than another. Students solve percent problems involving percent increase or decrease. So today we're going to be looking at increase, which is going to be increasing, going up, and decreasing, which is going down. Okay. Classwork, opening exercise. Cassandra likes jewelry. She has 5 rings in her jewelry box. In the box below, sketch Cassandra's 5 rings. Okay, so we're going to do our best to just sketch a little ring, just something that's representative of what our problem is asking us. We do not have to be artists. Clearly, I am not. 3. And 5. Okay. So, I did part A. Sketch them. Draw a double number line diagram relating the number of rings as a percent of the whole set. So the whole set is considered to be 100%. Okay. So this is going to be 100%. Okay. And then we have our number of rings. So that's where our double line, our second line comes in. Okay, so this is going to be number of rings and 100%. We have that there. Okay, so next we're going to look at, we have 5 rings. So, of course, this would be if we had 0 rings. 1, 2, 3, 4, and 100% is supposed to be our 5 rings. So that's not exactly spaced correctly. No, man. I undid everything. Let me try that again. Okay, so this is going to be 100. That's 5. 4, 3, 2, 1. Still not perfect, but that's okay. Okay, so 5 would be 100%. So if we're breaking 100 into 5 pieces, we're counting by 20s. So this would be at 4 rings, I had 80% of the collection. At 3 rings, I have 60%. At 2 rings, I have 40%. And at 1 ring, I have 20%. Okay. So what percent is represented by the whole collection of rings? So the whole collection, the whole is 100%. What percent of the rings does each ring represent? So each is 20%. The first ring was 20, and with the second ring you had 20% more, third ring 20% more, fourth ring 20% more, fifth ring 20% more, which gave us our full 100%. Okay, so let's go ahead, let's look at example number 1. Example 1. Cassandra's aunt said she will buy Cassandra another ring for her birthday. If Cassandra gets the ring for her birthday, what will be the percent increase in her ring collection? So we're looking at that opening exercise. And I know you may find it obvious, but we're going to take it a little step by step. So we're going to call this change, which is how much we're going to be increasing or decreasing by. Okay, that's our part. Then we still have percent, and then we have our whole, which is going to be our original. The original that we had, the original amount that we had. Okay, so finding a percent increase. So this already tells us that we're going to be finding an increase, but let's find it in our problem. Cassandra's aunt said she will buy another ring for her birthday. Okay, so she's getting one more, so they increase. She's increasing her collection by 1. Okay, we don't have anything that says anything about percent in here, so that's going to be our variable x. And then our whole is how many we started out with, our original. And so we started out, she had 5 rings. So write our equation. P is equal to percent times the whole. And then plug it in. P, we said, is 1. So instead of a P, I'm going to write a 1. Equals percent, I don't know. X. So, and then W is 5. So I'm multiplying those two things together. 1 is equal to, I'm rearranging that. Our coefficient goes in front of a variable. And then it's a one-step equation. I have multiplication, undo it with division. Okay, so that is equal to x is equal to 1/5. Now, it says what percent? 1/5 is not a percent. So we need to make it into a percent. So I have 1 over or divided by 5, which is equal to 0.2. 0.2 is equal to x. Again, it's still not a percent, it's just a decimal at this point. So we need to take that decimal and we need to move it 2 places to the right. 1, 2 gives us 20%. It is a 20% increase. And we can see that from our table above. Each ring was considered to be 20%, so if she gets 1 more, it's still going to be 20%. So it's going to be a 20% increase there. Okay, so we see exercise 1 next. It is very much like example 1. So go ahead and pause the video and go ahead and try that on your own, and then press play in order to check your answer. Exercise 1. John increased his trading card collection by 5 cards. So it's increasing and by 5 cards. He originally had 15. What is the percent increase? And in this case, it's saying it is going to be an increase. Use the equation quantity, and remember we said it's the same as saying part, is equal to percent times the whole to arrive at your answer. Then justify your answer using numeric or visual model. Okay, so we're going to have we need our P, we need our percent, and we need our whole. And we said our part is now going to be, in this case, how much is it increasing by? And so it's increasing by 5. We don't have a percent. That is what we are looking for, so that's going to be our variable. And then our whole is what we had originally. So what did we start out with? Which was he had 15 cards. Always write your equation first. P is equal to the percent times the whole. So P is equal to, so P we said is 5. So instead of a P, I'm going to write a 5. Is equal to x we said is going, or percent we said is going to be our variable. We don't know that. And then W is going to be 15. Okay, you're multiplying these two things, and we don't ever see it like this. Our coefficient is supposed to be in front of our constant. So it should be 5 is equal to 15x. You can change the order of multiplication, just like 2 times 3 is the same as 3 times 2. Okay, so that's all we're doing there. And then solving for x. So we're going to divide each side by 15 to get x by itself, because 15 divided by 15 is 1. And then we have 5 divided by 15. 5 divided by 15, which is equal to 0.3 repeating on forever. And if we would have simplified that, we would have seen it was 1/3, which is 0.3 repeating on forever. So 0.3 repeating on forever. I'm going to put 2 3s again, because this is one of our very common mistakes, is equal to x, because what do we have to do with our decimal? It's a percent. We need a percent. It needs to move 2 places to the right. We can only deal with a percent as a decimal or as a fraction, but we have to change it back. We have to go back and forth between the two. So 2 places to the right gives me 33% is my answer. A more precise answer, 33. Whoop, that's not more precise. It's giving me the exact same thing. My bad. 33 1/3, which is what we said the 1/3 is equal to 0.3 repeating on forever, or 33.3 repeating on forever. So this 3 will repeat on forever. Percent. Okay. Those are just a little more precise. All are acceptable in this case. It doesn't ask you anything specific. Part B. Suppose instead of increasing the collection by 5 cards, John increased his 15-card collection by just 1 card. Will the percent increase be the same as when Cassandra's ring collection increased by 1? In example 1. Why or why not? So when hers increased by 1, it was by 20%. This was broken up into 20%. Okay, and so if we look at this, his is already increasing by 5, and that's a lot. That's not at a 20%. It's not at a 40 or a 60. So that can help us. So no, because the number of rings are different than the number of trading cards. Okay, so just because they're both increasing by 1 doesn't make them the same. His started out with a 15-card collection. She started out with just 5 rings. So the original is what made it different. Based on your answer to Part B, how is displaying change as a percent useful? Okay, so representing a change as a percent helps us to understand how large the change is compared to the whole. Okay. So next we're going to have a little discussion. A sales representative is taking 10% off of your bill as an apology for any inconveniences. Discuss. Check out the next video, part 2, in order to see if you came up with the same ideas.